Okay, this video just is a PowerPoint discussion talking about Chapter 5 and Chapter 6, but primarily Chapter 5. And we start moving into the concept of probability and probability distributions. So a probability is a number between 0 and 1. And we capture or we determine probabilities based on data. We look at what's happened in the past and then we use that to predict the future by looking at the probabilities of how often things happen in the past. And Chapter 5 and Chapter 6, one of them is called discrete random variables, and then Chapter 6 is continuous random variables. And so we treat probability slightly different based on if the underlying data is something that we count or is it something that we measure. If it's data and all we can do is count, that's discrete. Or if it takes on a whole number. If it's something that takes on a continuous number, that's what we do in Chapter 6. So again, we'll review this again, the two types of random variables, and then we'll focus on discrete probability distributions and the binomial. So you're responsible for sections 1, 2, and 3. I'll have a video after this that shows you how to do binomial distributions and discrete probability distributions using Excel. So the random variable is just a variable where the outcome is uncertain. And it can either be a whole number, which is discrete, or it can be a number that's continuous. So if we're talking as an example of what would be a discrete, is if we had something and we were counting the number of mistakes or defects. Well, you can't get a part of a mistake. You either have a mistake or you're not. So the number of defects would be a discrete random variable. A continuous would be something that would be measured on a continuous scale. So time and money are very common continuous distributions. So the waiting time is something that you can have fractions. If you can have a fraction, it's continuous. If you have whole numbers only, it's discrete. So we need to talk about the term a probability distribution. What that is where we have every possible outcome and its associated probability. The outcome is variable is x and its associated probability is p of x. For every discrete probability distribution, the probability always is a number between 0 and 1, and if you sum all of the probabilities for all possibilities, it always has to equal 1. Not as important. We can calculate the average or the expected value. The mean or average or expected value, they all mean the same thing. How we can determine this is taking the outcome multiplied by its probability, and we do this for all outcomes, and that will tell you what the average or expected outcome should be. I'll show you how to do this in Excel. The notation is more difficult than the math in a spreadsheet. The variance is the same way. I'll show you how to do this in Excel. And then the standard deviation is the square root of the variance. So here's a good example of a discrete probability distribution. Let's look at selling radios. And let's say that in a day, the number of radios that we're going to sell is defined historically by this. So out of the last 100 days, we had exactly 0 days, or excuse me, the chances that we are out of the last 100 days, the times that we didn't sell anything happened 3 times. The times that we sold 1 radio happened 20 times. The number of days where we sold 2 radios happened 50 times. So this is based on historical information. The chances that the selling 3 radios happened 20 out of the last 100 days. Selling 4 happened 5, selling 5 happened twice. if you would sum these probabilities, 0.03, 0.2, 0.5, 0.2, 0.05, that would sum to 1. And then to calculate the average, we take the outcome multiplied by its probability. So we take this 0 times 0.03 plus 1 times 0.2 plus 2 times 0.5 plus 3 times 0.2 plus 4 times 0.05, 5 times 0.02 to come up with the average number of radios sold per day is 2.1. We can also calculate the variance, which is taking the difference between the average, which we just calculated, and the outcome. So 0 minus 2.1, square it, times 0.03, plus 1 minus 2.1, square it, times 0.2. We do all this for all possibilities, which was up to selling 5 radios a day. 5 minus the average, square that, times its probability, 0.02, to come up with the variance of 0.89, and then the standard deviation of that would be the square root of 0.89. A special type of a discrete probability distribution is the binomial. So the binomial is discrete, but we only have 2 outcomes. So if we would have one trial, then the success of one trial would be the probability of it. The best example is flipping a coin. If you flip a coin, there's only 2 outcomes. That makes it a binomial distribution. You either get heads or tails. But the binomial distribution could always also be used on if you got a cold or not, or got the flu or not, or defaulted on a loan or not, or got into college, a certain university or not, admitted. Anything where there's a yes-no can be considered a binomial distribution. And when you string these together, you can calculate the probabilities if you would have more than one trial, if you had n trials. Don't worry about this. I can show you how to calculate the probability using Excel. That's the long version, but in Excel it's much easier, and I'll have a video for that. But here's an example. Let's say that if you've got someone, let's say you're a salesperson at a store, and the probability that you're going to sell something is 40%. So for one customer to come in and buy something, the likelihood is 0.4 or 40%. So what is the probability that of the next 5 customers, exactly 3 of them are going to buy something? Exactly 3 out of the next 5, given that a success of one trial is 0.4. Well, this is how you would do this using algebra to come up with 0.2304. I'll give you another video to show you how to calculate that using Excel so that you don't have to worry about the combinations to do this number. In the back of the book, they give you a binomial table. You don't need that. I'm going to show you how to do this in Excel. We'll worry about this later. For the binomial distribution, you can always calculate the mean and the variance like what we did before, but because it's a special type of distribution, it's much easier to calculate the mean and the variance. All you do is take the number of trials times the probability of success of one trial, and that'll give you your mean. And your variance is the number of trials times the probability of success times 1 minus the probability of success. So Q is 1 minus P. So if P is 0.4, then Q would be 0.6. Here's a chance. Here's something, let's say the probability that a television is good or bad. And let's say the probability that you make a television and the chances of the television being good is 95%. So 5% of the time it's bad. What would be the average number of defects out of, average number of good things, good TVs, out of 8 if I produced 8? Well, the average number would be N, 8 times P, 0.95, so I would have 7.6 good TVs out of 8. I can calculate the variance by doing the exact same thing, and then if I know the variance, I can take the square root of that to get the standard deviation. Okay, that's good information for Chapter 5. I'll now show you how to do these in Excel. Thanks.